Hey, okay. So we're trying to, this is what we're trying to solve here. We're trying to solve this equation for t, and we're given the constraint that t is supposed to be in between 0 and 3. So I just went to Desmos to sketch the graph, right? 3 cosine 3x minus 2. And that's in red. That's this curve in red. And we're trying to see when this is equal to 0. So just from the graph here, we can see that we're going to have three different intercepts. And basically what we're trying to do is find those three intercepts. Now, to actually figure out what the intercepts are, I'm going to write down my equation and I'm going to try to solve for t. So I just added 2 to both sides, right? And then I divided by 3. So I got cosine of 3t is supposed to be 2/3. Now, I'm looking at the unit circle, and remember, cosine is the x component, right? So if I have, say, some value here of theta, then the coordinates for this point would be cosine theta comma sine theta. So if I'm trying to see when cosine is 2/3, that means I'm looking for, right, so this is going to be 1, this is -1, this is 1, and this is -1. So I need cosine to be 2/3. That's the x component. So it really might be, and I'll put it in red, if this is 1, and I need for my x value to be 2/3, then I'm going over like maybe 2/3 here, right? So I have like whatever this angle is here. So that could be 3t, or down here. So that angle could also be 3t, because cosine, say if I do it in green, cosine of this angle here, cosine of that angle is going to be 2/3, right? Because x value. Now, I could also keep going around. So I've got this one, and then I've got this one down here, right? But I could, for instance, go around like that to get back to this one, right? So I could have my original value plus 2 pi, or I could have my original value plus 4 pi, right? So plus 2 pi and then plus 4 pi. So whatever this value is, let's call that value alpha. So let's say that theta right there, let's call that alpha. And then let's call my green one, which is this angle that is in the fourth quadrant, let's call that beta. So 3t can equal alpha plus 2 pi k, right? Or 3t could be beta plus 2 pi k. So here, that angle beta is really actually the same thing as minus alpha, right? Okay, but now I go back to my restriction to tell me how many of these values I can have. So if t, remember the original equation said that t is supposed to be in between 0 and 3. I'm now looking at cosine of 3t, and I'm trying to see which values of which arguments have cosine of them equal to 2/3. And the argument can be anywhere between 0 and 9. So if t is in between 0 and 3, then 3t has to be in between 0 and 9. And I'm looking, and 9, I'm thinking about it, pi is approximately 3.14, right? So 9 is going to be a little less than 3 pi. So that means, excuse me, I can have this one, I can have this angle here, or I can have that angle again, right? So the only way I can end up with my 3t being between 0 and 3 pi is if I use alpha, and then I'll use alpha plus 2 pi, and then I'll use beta, and that's it. So if I, for instance, if I try to use beta plus 2 pi, then I'm going to be because this is pi, this is 2 pi, 3 pi, I'm going to be beyond 9, right? And I can't have that. And this matches the fact that there are only 3 values matches with our graph here that said we'll only have 3 intercepts. So now we use the calculator to get a decimal approximation for to get a decimal approximation for this right here. So we say, okay, well, if cosine of 3t is equal to 2/3, then that means 3t is equal to cosine inverse of 2/3. So this is going to give me alpha, right? So this is 0.8411. So, and I could take this and turn it into radian, but it doesn't really matter. So whatever this is 0.844. So now this is going to be minus, right? So this will be, I'm trying to get my 3 values here. So that's this one. Beta is going to be 2 pi minus 0.8411. And then this alpha plus 2 pi is going to be 0.8411 plus 2 pi. Okay, so I now have my 3 equations that I need to solve for t. So 3t equals 0.8411. That's one equation, right? That's going to correspond to the alpha. And then I have 3t equals 0.8411 plus 2 pi. And then my last equation, 3t equals 2 pi minus 0.8411. And that corresponds to that beta angle. So then if I just divide both sides by 3, and I'll get 3 equals, it looks like this is going to be 0.2804. And then here, if I divide by t, I'll get t equals 0.2804 plus, sorry, that should be by 3, 2 pi over 3. And that will approximately be 1.8, that'll approximately be 2.3748. Just doing this on my calculator here. And then this last one here is, we'll have t being approximately 1.8140. So that's how we get the 3 values. And we could check it just by saying, okay, if this is t in your calculator, you can compute what is 3 times cosine 3t minus 2, right, for this value of t, and you should get 0. And so you can double check all 3 of your answers, right? So hopefully that's helpful. Just as a summary, we're trying to solve this trigonometric equation for this certain domain. You can use the unit circle to tell you where the kind of where the reference angles are. And then, you know, each of those plus 2 pi k is a possible solution, right, to your equation. When you're going to restrict your domain, that now tells you which of all of these solutions to actually use. So for us, we ended up only being able to use the alpha plus 2 pi, and the beta, okay? All right, I hope this helps. Let me know if it doesn't help or if you have questions on this little video.